A black diamond Zareba unit came to us for repair. Black diamond is just a marketing thing. It's a metal case, diamond plated, but the inside's all plastic. It's just a marketing thing. But anyways, we're going to take a look at this, see if we can get it going. Hopefully we got the parts here for it. But see in just a little bit what happens. If you'd like to subscribe to the channel, we'd be happy to have you subscribe. If you want to hit the thumbs up button, if you already have subscribed, that'd be great too. We do work on all brands and models of electric fence starters. We're having a little difficulty with parts on certain ones, certain brands. So that's been a kind of a hurdle for us to overcome, which is still going on today. So we're gonna take the screwdriver. I'm not gonna plug it in. I'm just going to open it up, and we'll just see what's going on first. Do some tests on the inside. Our website, there are links in the description area below. It is a fencerfixer.com. I'll take this metal plate off. See, it's just plastic on. Ooh, water damage. Look at that board. It is smoked. This board is shot, and the transformer is burned up too, possibly as well. But it needs a board. That's the key thing we've got going on, because this board is no good. So I don't know if this unit was indoors or not, or outside or not. But if it was inside, man, you got a bad leak in your building somewhere. But if it's outside, well, this is what happens. Water damage. These things are not sealed units. No AC model is designed to be outside unless you got it protected in a box or something like that. So, like I said, this plastic, there's metal case in the back, has this little thing there. It sits over that. There's no seals between, this piece and this piece, or this metal piece here and this metal piece. This is sandwiched together. So, but that board is shot. So let's check this transformer out real quick. We'll do a test across the primary side. We're going to ohm it out. Should be 0.1 to 1 ohm, somewhere in that range. There's no polarity to it. So, let's see, it reads 0.3 ohm, 0.2. So, the primary is fine. Secondary side, I don't know what it's supposed to read. 6.5, 7. I don't know. Oh, that's good or not. All these transformer primaries or secondaries are all different from brand to brand, model to model. Unless they're the same transformer in different models. But I know the primaries are universal on all brands. It's a closed loop to allow the board to discharge its energy out of itself. Okay, so what we're going to have to do is, because this board's shot, we're going to have to get another board for it. I don't have a board for this model in stock. The company that makes Zareba owns them. Not discontinued, but as of November 1st, decided not to supply parts anymore. So whatever parts were available through their distributors and stores and stuff like that, and that's all we got. So what we're going to have to do, we're going to take this board. It's a 1 joule board, but we're going to have to make a few changes to it and turn it into a 4 joule range board. And the way that we do it here, we change out this diode to a bigger one. Think we can keep that in there, this SCR. We'll have to change out at least 3 of these capacitors to a little bit bigger ones. We keep all these the same because I've done 4 and 5 of them before, but we do that. It doesn't really make any real big gains doing that. There's probably more you got to do to really get the power boosted up. But if we change out at least 3 out of these 4 small ones right there to the next size bigger, or to some bigger ones, usually we're in good shape to get in that 4 joule range. So I think what I'll do, I'll change, because I know if I change that to 3, I can get to about 5 joules, roughly, probably about 4 joules. But so I might just change 2 to start with, check it with my joule meter, and see what it goes up to. If we need to change a 4th, 3rd one, we will. But Let's just see what happens. So first thing we need to do is, let me go get my components that I need, and then we'll get some capacitors with the diode changed up to a bigger one because we're going to be punching more power through, so I want to protect things a little bit more. So let me grab some parts. Alright, so now I got my 3 capacitors, get my bigger diode, and we're going to desolder the diode out of there, and then we're going to go ahead and change out the 3, these 2, and one of these. It won't really matter which one of those we change out. And should be able to make this board work. So, alright, so let's zoom in here so you can see what we got going on here. So we're going to use this stuff here. It's made by a company called Kimwick, or Kimtronics. It's a desolder braid. It's got flux rosin stuff built into the braid, which helps the solder flow and allows this stuff to suck it up real good. It's about $20 for this roll. It's about it's a 150-foot roll. Lasts us about 6 months to a year, depending on how much we use. But there's cheaper stuff out there. It's like $7, $8, but it's only like 5, 6, 7 feet. And this is a 50-foot roll. So this is good stuff. This stuff works really, really good. I've used the cheaper stuff, and man, it doesn't have the stuff built into it, and it takes forever for the flux to, or the solder to flow up into it and come out of there. So we're going to lay this across like this. Got my tip of my iron cleaned off. Heat up, ready to go. So we're just going to lay it sideways and let the thing kind of heat things up. And I want to go to the back side over here. Pulls it right off. And you can kind of see it down there. I think a little bit more on there. God, it's hot. Okay, I think we got it there. Here, same thing. Sucks it right off there. And a little backside just to make sure. Just push firmly up against it. Okay. Flip this over. There's a pair of pliers. I should just be able to grab. Oh, God, that stuff is hot. Fuck, you put my finger on it and burning myself. Alright, so I got that out of there. So now we're going to do the resistors, or the capacitors, I'm saying. Alright, so now we're going to go on this one here. That unit itself, it is a age-wise about 2015 model. There's a serial number on there. It said 15 on the first 2 numbers. That's the year it was built. Ow, damn, it's hot. This one here. That's gone. Go to this one. And we'll go to this one next. Another thing that helps is having a good soldering iron. We do there's cheap ones you can get, and they'll be like rated in watts, like 15 watts, 30 watts, 40 watts. I never know what the temperature that is, but every place I've ever worked at that had soldering irons didn't go by the wattage. They used the soldering irons were all digitally controlled with a temperature gauge on there. And most places that I ever worked at, the temperature was usually between 750 and 800 degree Fahrenheit. And every place I've ever worked at, that's what they always had them set at. So every time when I bought mine years ago, that's my set right. I just I can adjust it, but I usually kind of float between 750 and 800. I think that one will go up to like 900, which I don't really have to go that high unless we got a really stubborn thing that really needs to be heated up. Because that heat, you get too high for too long, and it ruins your tips. It ruins the tip of your iron. It gets too hot and just degrades over time. And the other thing is having good quality tips on there. There's some cheap tips out there, and they don't flow the heat very well at all. And so what we do is we buy a cheap iron, and we'll change out the tips to good quality ones, and it saves us a bunch of money and not have to buy the high-end iron. So, trick of the trade. All right, so you got the picture of the diode with the little spot up here. That's the stripe. So you look at a diode, has that little stripe on there. So that's where the stripe goes. Because these are a diode is like a check valve, basically. It's like a one-way device. Allows current to flow through one way, but not the other. It's usually used to protect things from backfeeding, going the opposite way. Capacitors of this type do not have a polarity, so we just plug them in to the right holes they need to go in. Let's keep our hands on them. Go out. All right, I'm gonna keep my hands on hold them like that, so because they're not tall enough to rest on the board, so they want to fall out. So now what I do, because I don't have my second hand to help me, put the solder on while I'm holding the iron. I'll get some solder out. Make sure the iron's clean, the tip's clean, and I'll add quite a bit of solder on there, and I'll just touch one side of it. That will hold. It's not very good. You go back and touch it up, but that's basically holding while I do the other side. So I'm going to do it to one side of each capacitor. So now I can pull my hand off and those hold still. So now we'll go back and we'll solder the one side that we didn't touch on each of the capacitors. Do it the right way, And then we'll go back and we'll touch up the other ones that we just kind of reflow it, add a little bit more to it, and come over here and solder in the diode. This one's not quite in all the way, so I'm going to heat that. See, this one, capacitor's not in all the way. It's kind of sitting up off the board on the one side. So what we'll do is we'll put a little pressure on the front side of the board. Our finger will kind of squeeze on it a little bit. Heat up this one side. See here, it come all the way through. That side did the same thing on. There's that one come all the way through. Okay, just touching up that one a little bit. Alright, so now we'll snip off the excess on this diode. There's way too much sticking out. Okay, let's get zoomed out here. Okay, so the board, set the board down just about far enough and set like right about there. Not quite as long, so there's a little slop there. But I think once we put the lid on there, it'll probably hold just fine. We'll find out here in a minute. We'll take this transformer here, so it's not a little slot there. Now these terminals are pretty crusty looking because of the corrosion from the board. So I'm going to see if I can just take a Dremel tool, the wire brush, and clean those up. Now these, let's see, hopefully we can make the transformer leads work. If not, we're going to have to cut them off and make them longer. Good. Okay, now let's get the cord off the old board. And we'll take those snips we had earlier, snip off the spade connectors off there. And we'll strip back a little bit. And then we're going to add a little solder to them. This is going to stiffen them up so they keep their shape and the little strands of copper don't come apart. Call it tinning the wires. And then we'll take this cord, need a small flat screwdriver, got the screw down terminal here, you just need to loosen it up a little ways to open up the holes. And the fuse is on the left hand side, so that usually where the neutral wire goes in on that side, so we're going to put the white wire on the left. And then we'll take black wire on the right. cord's going like that. And if we need to, we can put a couple of little pads of double-sided foam tape. We'll double them up in the middle there, and that will take up the space right there, plus probably help hold it to the plastic there. But let's plug it in here. Oops. Let's get these transformer tabs here plugged on. Let's plug this in. See what it does. Okay, it's clicking again, so we're working fine there. Let's see if the light was flashing on this down here. It might be hard to see in the camera because sometimes the camera's frame rate doesn't pick up the flashing light. It is flashing, but it is hard to see. Alright, let's put the lid on it for a second, and we'll put our get our meter out that can test the joules, and we'll see what it actually puts out joule wise. Let's put at least a couple screws in it to kind of help hold this piece on, keep that board in place as well. That board's staying put, so I'm going to put any tape on it at all. Okay, we're going to loosen these terminals up. We're going to get our fancy dandy meter here. And we're going to, let's see, left is a ground. We're just going to use this to kind of help hold these leads on there so we can get our other hand free. Alright, we're going to look at peak voltage with no load. Alright, so we'll look at this number, see what that transformer, I think they're usually right around, kind of guessing, 8,000 plus or minus. Yeah, 8,007.8. Alright, no, 9,000 volts there for a second, but about 8,000 what's kind of floating around it. Let's go to 1,000 ohm load. We're at 0.8 joules, almost 1 joule. We're at 6,000 volts. Let's go down to 500. 1.1 joule. Down to 200 ohm. I don't think we're going to quite make 1.2 joules. All we can get out of it. Okay, we're going to make a little change here. Alright, let's unplug the unit. Let's take these leads off. We're going to make a change to the big capacitor on this. Okay. Okay, so now what we're going to do, there's a big capacitor on there. We're going to have to change that out to a bigger one. Which is, unplug this wire first. So I know the transformer itself is good. So what we're going to do is we're change out this big one here to, let's see what size is it right now. It is a 4.5 roughly microfarad, so we're really going to have to jump that up to get the joules even higher. So let me go look around here for a bigger capacitor. Alright, we're going to put this capacitor in. Now see, this is way too big physically to fit on that board. So what we're going to do is there's two ways of doing this. We're either going to desolder this one off and hardwire the wires off of this onto there, and we can put the capacitor like back here somewhere or something. Or actually we got a little bit smaller capacitor. And then if we have a smaller one, we can take it, leave this one on there, that big one there, leave it on there, get the next size smaller of one of these. It's a 30, and then that would bring us up to like 35 roughly microfarads altogether. So it'll be pretty close to what this one would have been on its own. So that's what we're going to do. See, it's physically not as big as that 40. I gotta be careful with board. These capacitors are probably all charged up, so I gotta be a little careful. But as long as you don't touch the board across those terminals, you're all right. And you use unplug, so there's no power going to it. But those capacitors still are charged for quite a while. All right. Let's see. We need to get some wire soldered on there. I'm going to grab some 14 gauge wires. Way overkill for this, but it's what I got handy here at the moment. Actually, I've got some other stuff here. Where'd it go? Some smaller gauge wires that could probably actually be a lot easier. Yeah, here it is. Be a lot easier to work with it as well. This is 18 gauge or 20 gauge, something like that, but solid strand, not solid wire, not stranded. So we're going to see how we're going to fit this in there. So we're going to take this. It's going to sit like this. And we're going to run wires, one wire off of this side, another wire off of this side, come off of it and go to the back side of the board. I think if we move this capacitor or transformer up out of the way, probably put the capacitor right there. Let's see, I have to center it like that. And put some double-sided foam tape on this to help hold it in place, or glue it. Maybe we'll just glue it in place. We'll figure it out when we get ready to do the final deal on it. But let's keep the capacitor there when we got it. Let's get some solder on the wire here. And then we're going to go off this one here. I'm also going to solder over here to this one. And then we'll heat them both up together. Cut it kind of long so I can cut the wire off. Okay, let's flip this board over. The only thing I worry about doing this is if this SCR is not, it may not handle this extra punch that this capacitor is shoving through it. It may work for a little bit, but it may only last 5 minutes. I don't know, who knows. But if that happens, we'll have to change that out. But I don't want to change it out if I don't have to. I'm trying to keep the cost down, everything for parts and everything for the customer. Let's get these wires pushed down. Board, the cord back in its little spot there. Let's get but what we'll do is before we call it done, the customer, we will let it run for a full 24 hours and make sure everything is kosher with each other. Okay, let's get our leads over here on this meter. I'm going to turn that on and get it ready. Get the ground hooked up. I'm going to go 500 ohms. Plug this unit in and we'll see what kind of joules we get on there. Alright, we're 2.5 joules. 200 ohm. .7, 3.6, that's close enough. Let's see what happens when we go to 100 ohms. It'll probably be over its threshold, but we'll see. 100 ohms pretty hard on a unit this size. Yeah, didn't gain anything doing 100 ohm. So 3.8 ohm, 3.8 joules what we got to. That's pretty darn close to 4. So close enough that a 0.3 joules not going to make a difference with the rest of the unit. So now we'll get things tightened up on the inside, that capacitor, and we're going to let it run for a while. Make sure that the transformer Now, the transfer will handle it because it's made for a 4 joule unit. That's what this unit is, a 4 joule output. But we got to make sure that the board will, yeah, the SCR on that board will handle it. Come on. Come on. Come on. I think the board will be fine. Once we get the case lid on there, I think we'll be just fine. Smells like mail. It might be here. All right, take this big resistor here. We're going to discharge capacitor. Just hold it there for a minute. Get some of this. Now I can kind of handle things a little bit without risking to lessen the chance of getting zapped by the capacitor. I'll take some of this pre-cut double-sided foam, and then we're going to grab some of this transfer kind of out of the way for a second. We'll take this, put it on the back side, squeeze it on there real good. Okay. Nothing more on loose, so we should be good there. And the light is indeed flashing. I can see it a little bit better now for whatever reason. Let's put a screwdriver across it and see what kind of spark this thing will throw. Let's hope it's shot coming from it. It's like it says right around a 4 joule, like 3.7, 3.8 joule output. So this is a 4 joule unit, I believe. Yeah, 115V, 115 volt, 4 joule. I don't know what the 6 is, but that's 115 volt unit, 4 joule, 2015 model. Good to go for now. I'm gonna run it for a while, make sure we're on the, make sure everything's running good. Then we should be good to go. But thanks for watching the video here. Until next time, see you guys later on, and have a good rest of your day.